Let's continue looking at some other questions from our semester exam review. I'm starting here with question number 7, the graphs of sine and cosine. And for this first problem at question number 7, it looks like we've only got 2 transformations to our cosine function here. Actually 3, if we want to count that negative as well. But I'm going to start here with the 3. That 3 in the front, remember that changes the amplitude of the function. So my amplitude for this graph is going to be 3. And then the 2 that's being multiplied by the x, that's going to affect the period. And for our period, we're going to do 2 pi divided by that number in front of the x, which is 2. And that would simplify to pi. Okay. So I'm going to draw my axis down here. And on the y-axis, we'll just count by 1s. That should be fine. On the x-axis, I think I'm going to make pi be here. That's my period. And typically, I like to have at least 4 squares for the period, which would make this pi over 2. And then 2 pi would be here. All right, we don't have any horizontal shift or vertical shift, so our graph is going to start here on the y-axis. The amplitude is 3, and so that means from our midline, which since we don't have a vertical shift, our midline is just the x-axis. From there, I'm going to count up 3. 1, 2, 3. There's the top of my graph. And from the midline, I'm going to count down 3. 1, 2, 3. And so that would be the lowest points on the graph. Again, the period is pi, so that means I need to complete a full cycle by the time I get to pi. And I'm going to draw that line right down the middle, and there's our window pane for graphing. So I think I'm ready to sketch the graph inside. This is a cosine function, and so normally cosine starts at the top, but this happens to be a negative cosine function, so we're going to start at the bottom. It's going to hit the maximum in the middle, back to the minimum at the end, and those zeros halfway in between. I'm going to go ahead and repeat the pattern one more time so that we can sketch 2 cycles. And there we go. Let's look at the next question. In this one, we actually have all 4 transformations happening to our sine function here. So before we start sketching, let's think about each of these transformations. First of all, the 2 there in the front. That, of course, is going to change our amplitude. Amplitude is normally 1. This is going to have an amplitude of 2. Period is going to be affected by this 1/2 here being multiplied by the x. And so to find the new period, we're going to do 2 pi divided by 1/2. And that's equal to 4 pi. This minus pi over 2, that's going to give us a phase shift or a horizontal shift. And it's going to move to the right. Pi over 2. And finally, the plus 1. It's going to be a vertical shift, up 1. You can also think about that as the position of the midline. The midline is going to be at 1. Okay. So here's our axis. I'm going to count by 1s on the y-axis. And on the x-axis, we've got that shift to the right, pi over 2, and I also have a period of 4 pi. So I need to choose units so it will be convenient for me to graph both of those things. So I think I'm going to make this be pi, have every grid be pi over 2. And that'll make my shift easy to graph. So that means that's pi. Here's 2 pi, 3 pi, 4 pi right there. And then if I'm going to do a second cycle, let's see, 4 pi, 5 pi, 6 pi, 7 pi, 8 pi. We'll need to go all the way out to 8 pi, actually a little bit past it to get 2 cycles. Okay, so in drawing the window pane, I like to start with the midline, which is going to be right here at 1. And our horizontal shift, right, pi over 2. So normally we would start on the y-axis. We're going to shift that over pi over 2. From the midline, our amplitude is 2, so I'm going to count up 2. So that means my high points are going to be here. And I'm going to count down 2, so my minimum points are here. The last thing we need is the period, which is 4 pi. And so if I count from 0, 4 pi is here, but remember we've shifted over pi over 2. We've shifted over 1 unit on our graph. And so really our period is going to end here at pi over 2 past 4 pi. And we find the middle here. There we go. There's our window pane. So we're ready to graph our function. This time it is a sine function. Sine starts in the middle. And it's a positive sine function, so we're going to go up, back to the middle, down to the minimum, and then back to the middle. And then I'm going to go ahead and repeat that cycle so we can get two periods graphed. And there we go. Now on the next question, we've got a graph here. We're just asked to determine the period and the amplitude. So let's start with the period. Remember that the period is the distance that it takes on the x-axis to complete a full cycle. And so what we need to do is identify a point that we're going to consider the starting place of the cycle and a point that we'll consider the ending place of the cycle. So if I choose this point here as where my cycle is starting, then the cycle ends and starts over again right here. And so that means that the period of my function is going to be the distance between these two marks, which is pi. The amplitude, that's going to be the distance from the midline to the top or from the midline to the bottom. So it looks like our middle is right here. And if I count up to the highest point, that's 1, 2, 3. And from the midline, if I count to the lowest point, that's also 1, 2, 3. Just to confirm I got that in the middle. That means our amplitude is 3. Now we've got the same graph, but here we're asked to identify which of these equations does not represent this graph. And we had an amplitude of 3, and if I look at my equations, they all have 3's there in the front. We had a period of pi, and to find our b value for our function, sorry about that. To find the b value for our function, b is going to be equal to 2 pi divided by the period, which in this case is pi, and so that simplifies to 2. But if I look at all my equations here, they all have that 2 there. So in order to, and actually if I look at them all, notice they all have a plus 2 on the end. So the main thing that's different here is the horizontal shift, and this one up here doesn't have one. And then we're looking at whether it's cosine or sine. So I'm going to start by just sketching that midline, just to give us a reference point to figure out if it's sine or cosine. And let's just start with the first equation. So equation A is has no horizontal shift, which means it's starting at the x-axis. And if I choose, if I have no horizontal shift, if that's 0, that corresponds to this point up here, which is at the top of a cycle, which would make it a cosine graph if I'm starting there. And that is the equation that we have here. It's a cosine equation. So that equation works, which which means it's not the answer that we're looking for. We're looking for the one equation that does not work. So let's try the next one. This time we've got a minus pi over 2, which means our horizontal shift is going to be to the right pi over 2. So I'm going to find that mark right here. That corresponds to this point in the cycle, which is at the bottom of the cycle. And so that would correspond to a negative cosine function. And that is what we have here, cosine with that negative in the front. So again, that equation works. All right, next one. Looks like we have minus pi over 4, so that means a shift to the right pi over 4. So we're going to shift right here. That corresponds to this point on our graph, and that point is in the middle, so it means it is a sine, an equation for a sine function, and from that point we're going down, and so that means that it should be a negative sine function. And on C we have sine, but there's no negative in the front. If we look at D, everything on D is the same except that it does have the negative in the front. This is that sine equation with the negative in the front. And so D does work for our graph. C is the answer. C is the one that does not represent that graph. All right, question number 9. We're asked to sketch a graph of this scenario. The London Eye is the tallest Ferris wheel in Europe. Passengers enter the wheel at the bottom from a platform that's 15 meters above the ground. The wheel is 120 meters in diameter. Takes 30 minutes to make a full revolution. And so first off, we're going to sketch a graph. So I'm going to put a mark here and label it 15. So our passengers are getting on the Ferris wheel at the beginning of the ride. They're already at a height of 15 meters off the ground. And let's see, it says it takes it 30 minutes to make a full revolution. So I'm going to label that 30. So by 30, I should be back down here to 15. They told us that the diameter of the Ferris wheel is 120 meters. And so when we get on the Ferris wheel, if we're already at 15 meters, and then the Ferris wheel is going to go up another 120 meters, that means that our highest point is going to be at 135 meters. And since it takes 30 minutes to go all the way around, we're going to hit that highest point. We're going to be at the top of the Ferris wheel at 15. So a cycle on the Ferris wheel would look like this. We're also asked to write a sine and a cosine equation. And so if I'm going to be writing equations, I need to figure out where the middle line is. If my diameter is 120, then the halfway point would be 60 meters above where we started. And remember, we got on the Ferris wheel already at 15 meters, so if we go halfway up the Ferris wheel, we're going to be at 75, 60 meters above 15. And so that 75, that should be the mid line of our graph. So I'm going to write, I think I'm going to write a cosine equation first because we have the, we're starting at the bottom of the cycle. Our amplitude, remember the amplitude is the distance from the middle to the highest point, distance from the middle to the lowest point, and we just figured out that that's going to be 60. The period, actually we don't need the period, we know is 30. What I need is the b value. Our b value is going to be equal to 2 pi divided by that period, which is 30 minutes. And so that simplifies to pi over 15. For c, that's going to depend on which function we're writing. For right now, our c will be 0 because we're going to write a negative cosine function. So we have no horizontal shift for that. And then d, of course, that's our midline, which we determined is at 75. So to write our cosine equation, y is equal to We're writing a negative equation because we're starting at the bottom of the cycle. My amplitude is 60. Cosine of my b value, pi over 15, times x. We have no horizontal shift, but our midline, our vertical shift, is at positive 75. All right, now if we're going to write a sine function, I'm going to go back to my graph and I need to identify a starting point for sine. Sine starts in the middle of the cycle, and so that would be this point right here. I need to figure out what x value that x value is represented at that point, and that's going to be halfway between 0 and 15, so that's going to be 7.5. So to write our sine function, y is equal to 60, and let's go back. Notice when we start there at the middle at 7.5, we are going up, so this is going to be a positive sine equation. Positive 60 sine b value of pi over 15, and then this time we are going to have the horizontal shift to the right, 7.5, so we're going to put minus 7.5, and then finally at the end plus 75. Now there are other correct answers, but these are the two, one cosine and one sine equation that I've chosen to do here. Next up, they ask us how long does it take for the passenger to reach a height of 100 meters from the ground. So this is where your calculator is going to come in handy. We need to type in one of the equations that you just wrote, either the cosine or the sine equation. And then you need to also type into your F2 function this 100 meters. And if we do that, you should end up with a graph that looks like this, after, of course, you adjust your window to be able to see that graph. What we're looking for here is this intersection point right here. And using your calculator, you can determine that that intersection point is at x equal to 9.552 minutes. So it takes 9.5 minutes to reach a height of 100 meters off the ground. Now the next question asks us to determine what is the height of the passenger 25 minutes into the ride. So this time we're given an x value, a time, and we just want to substitute that into the function. You can do this on your calculator page, and since we have that graph typed into F1, we can just type F1 of 25, and that'll give us the result of 45, and that means that after 25 minutes, the height of the passenger on the Ferris wheel is 45 feet.